Hi, I'm Tutor Frank. Welcome again to today's class. Today we're going to continue from where we stopped yesterday, and we'll be looking at differentiation. Differentiation. So today we're going to begin from techniques of differentiation. Techniques of differentiation. Now, what are the techniques we apply when solving differentiation questions? Number one, derivative of a constant. Okay, now how do we differentiate a constant? Now, by a constant, what do we mean? A constant is simply an item with no variable. Variable simply means your letters. Okay, the letters of the alphabet like A, B, C, D, X, and so on. Okay, so when you have an item with no variable, it is referred to as a constant. Or at times we refer to it as numbers. Okay, now how do we differentiate constants? Take for instance, if y equal to c, now this can be written as y equal to c x raised to power 0. Don't forget these c's are constants. Okay, so if c is a constant, now a constant simply means there is no variable. Now this is what it means. If y is equal to c, it means that the variable's power is equal to 0. So y equal to c x raised to power 0. Remember, I told you any variable raised to power 0 in mathematics equals 1. So c times 1 gives c. So when there's no variable attached to the constant, it simply means that the variable's power is equal to 0. Now look at this. Y equals c x raised to power 0. Remember from our class yesterday, I said this initial power, we multiply this constant. So 0 times c times x raised to power 0 minus 1. Okay, now 0 times any variable, whatever it is, equals 0. So our final answer is 0. So that therefore means that the derivative of any constant is always 0. Now this is a law. This is a law in mathematics. The derivative of any constant, I mean any item with no variable, with no letter attached, equals 0. Now technique number 2, derivative of sum and difference. Sum and difference. Now this is done separately without affecting the sign. Now take for example, if y equals x raised to power n plus or minus x raised to power z. Now differentiating y with respect to s, we solve them separately without affecting the sign. So we differentiate this and then we differentiate this. Of course, the sign remains intact. Now, how do you differentiate this? Don't forget the power, initial power, multiply the x, then you subtract or you reduce the power by 1. So nx raised to power n minus 1. The sign remains the same. The same thing here. The initial power multiply the x, zx, then you reduce the initial power by 1, z minus 1. Okay? Now, derivative of products. Products simply means multiplication. How do we differentiate products? Now take as an example, if y equals uv, now where u and v are expressed in terms of x, how do we differentiate them? Now first thing first, you keep the first constant, that's u constant, then you differentiate v, then plus the plus sign, then you keep the second constant, that's the v now, indicated by v, and you differentiate the first. So we keep the first constant, differentiate the second, plus we keep the second constant and we differentiate the first. Now, derivative of quotient or fraction. Quotient simply means division. Okay, so how do you differentiate a division question or a fraction? What do you mean by fraction? Having a numerator and a denominator separated by a dividing line. Now, as an example, if y equals u over v, where u and v are in terms of x, how do we differentiate? Now, dy dx equals v, that's the denominator. We keep the denominator constant, then we differentiate the numerator, du dx, minus, now we keep the numerator constant, u, and we differentiate the denominator now, dv dx, all over the square of the denominator. Okay? And then the fifth one I have here is higher derivative. Higher derivative. Now, dy dx is normally called the first order derivative. Okay, then d square y over dx square, as you can see here, is called the second order derivative. Now we're going to take some calculations from past questions in JAM, further mathematics, and of course the WAEC and NECO past questions to drive home our point. Come with me.
Let's go.
Alright, now we have a question on the board. Calculations on differentiation. Now, if y equals 2x plus 3 over 5 minus x squared, differentiate y with respect to x. Differentiate y with respect to x. Now, let me see if you are following. Now, under what technique can we classify this question? Remember, 2x plus 3 over 5 minus x squared. Under what technique? Yeah, the quotient or the fraction. So this is derivative of quotient or fraction. If that's what you said, then you are correct. Because this is a fraction, a numerator and a denominator separated by a dividing line. So this is derivative of quotient or fraction. Now don't forget the established relationship. Don't forget the theory I gave. I said if y equal to u over v as an example, what is the rule? dy dx is equal to v du dx minus u dv dx over v squared. Okay, so what that means is that we keep the denominator constant, we differentiate the numerator, minus we keep the numerator constant, we differentiate the denominator all over the denominator square. Okay, now that's the rule. Now let's now link it to this question. Now y equal to uv, u is our numerator and v is our denominator. Okay, now looking at this question, now u will be represented by what? U will be represented by what? 2x plus 3. So u equals 2x plus 3. Don't forget, u is our numerator, 2x plus 3. Now, if u equals 2x plus 3, now differentiating u with respect to x now, that's my du dx is equal to what? Now, don't forget 2x. The power of x is the same as 1. In mathematics, x is taken as x raised to power 1. A is taken as a raised to power 1, okay? Now bring this 1 to multiply the coefficient of x, which is 2. Now 1 times 2 gives 2. Now when you do that, you reduce the power of x by 1. So 1 minus 1, which is 0. So this gives 2x raised to power 0. Now don't forget, in mathematics, any letter raised to power 0 equals 1. So x to power 0 is 1. So this is taken as saying 2 times 1, which gives us what? 2. That means differentiating u with respect to x, du dx gives us what? 2. Now let's move to denominator v. Now v now, which is the denominator, equals what? 5 minus x squared. So next we're going to differentiate v with respect to x. So dv dx equals, remember 5 is a constant. Why is it a constant? No variable is attached to it. And remember what we said, differentiating a constant equals what? 0. So this 0 minus, now look at the power. The power here is 2. So 2 is going to multiply the coefficient of x. Now, x squared, automatically the coefficient is what? 1. Okay? A in mathematics is written as 1a. B is written as 1b. X squared is written as 1x squared. So 2 multiplying 1, that gives us 2x. Now, I reduce the power by 1. Okay? So this gives me 0 minus 2x raised to power 1, which is written as minus 2x. So the derivative of v with respect to x now, dv dx equals minus 2x. So now I can fix it back into my formula. That means that dy dx equals v. We are keeping v constant. What is v constant? That is 5 minus x squared. Okay. Then du dx. What's my du dx? 2. Alright. Then minus u, we are keeping u constant. Now what is my u? 2x plus 3. That's 2x plus 3. Alright. Now dv dx, differentiating v with respect to x, that gives us minus 2x. Alright. Over what? V squared. V squared. That's 5 minus x squared or squared. Now we're going to expand the bracket now. Alright. So 2 will multiply everything inside this bracket. 2 times 5 gives 10. 2 times minus x squared minus 2x squared. Alright. Then minus. Now, because it's a negative number, I'm going to put everything in brackets. Alright. So that it does not affect this minus sign. So minus 2x times 2x gives minus 4x squared. Alright. 2 times 2, 4. X times x squared. Then minus 2x times plus 3. Minus times plus in mathematics gives minus. So 2 times 3 gives 6x, alright? Over, I have my 5 minus x squared or squared, alright? I believe we're together. Now let's go. Minus is going to multiply everything in the bracket. So that gives 10 minus 2x squared. Now watch this. Minus times minus